GATE 2014 Civil Engineering Set 1 Question 50. A traffic survey conducted on a road yields an average daily traffic count of 5,000 vehicles. The axle load distribution on the same road is given in the following table. The design period of the road is 15 years. The yearly traffic growth rate is 7.5% and the load safety factor is 1.3. If the vehicle damage factor is calculated from the above data, the design traffic needs to be found in million standard axles. The relevant NPTEL reference has been listed. So, to find the cumulative standard axle, also abbreviated as CSA, the equation is 365 into A into 1 plus r to the power n minus 1 divided by r into the vehicle damage factor into lane distribution factor into load safety factor, as in this case. So A is the daily traffic on the road, r is the annual growth rate in percentage, n is the design period of the facility in years, VDF is the vehicle damage factor, LDF is lane distribution factor, and LSF is load safety factor. VDF is found using the equation summation of Fi into the load of each category divided by the standard load raised to the power 4. LS is taken as 8.2 tons as per IRC code. So in this case we have been given the load distribution in tons and the frequency of traffic. So we need to find the vehicle damage factor. So firstly we will find the corresponding coefficients, which would become 23.21. For the next one we would have 14 by 8.2 to the power 4, which would become 8.496. The next one we would have 10 by 8.2 to the power 4, this would become 2.21. For this one we would have 8 by 8.2 to the power 4, which would be 0.906, and next one would be 6 divided by 8.2 to the power 4, that would become 0.2866. So now we need to find the vehicle damage factor, which is given as the summation of the frequency into Li by Ls to the power 4, which was computed on the left side. So this would become 0.1 into 23.21. We will convert these values into decimals, plus 0.2 into 8.496 plus 0.35 into 2.21 plus 0.15 into 0.906 plus 0.2 into 0.2866. This value would turn out to be 4.986. Now we know that cumulative standard axle is given as 365 into A into 1 plus r to the power n minus 1 divided by r into the vehicle damage factor into load safety factor into lane distribution factor. In this case, A has been given as 5,000 vehicles per day. Growth rate has been given as 7.5%. The design period of the facility has been given as 15 years. Load safety factor is mentioned as 1.3, and since lane distribution factor is not given, it will be assumed as 1 in this case. So this would become 365 into 5,000 into the rate will be taken in decimals raised to the power 15 minus 1 divided by 0.075 into 4.986, that is vehicle damage factor, 1.3 that is load safety factor, and lane distribution factor, that is 1. This would turn out to be 308,961,580 standard axles. In converting this to millions, we would operate this with 10 to the power minus 6. So this would turn out to be 308.961 million standard axle, which can be rounded off to 309. So the design traffic in million standard axles is 309. The relevant NPTEL reference has been listed.